Okay, you can.
Yes. Okay. So as of now, in our CAN test bus simulation, that means CAN RBS, we are able to transmit some values by the manual values, which means normal signal. So now choose normal signal. Here we can generate some values like, for example, 100. The value we can 100. We can mention here. So one more option is that we can set as a set rolling counter. Some of the values are automatically running based on rolling counter limit values. So now we can change this again, normal signal. So one more input source is our track bar or these kind of read and write signals. Track bar controller. So here we can adjust some values. So based on that, this and then RBS values change here. So as of now we have only three input sources we know about that for the RBS simulation. So if you are using the transmit window, it will not reflect in our RBS also. So in the initial stage we are working with the analysis column of transmit window. So here we are working with some algebra properties also like RAM samples, value range, random. These will not reflect to our RBS simulation. So the RBS simulation is an entirely different part. It is looking like a software in the loop simulation. But this transmit part is for our analysis purpose. We are having some triggering options. So it means without hardware we are able to trigger like a real-time hardware. So that is the option of transmit window. So next one is that rest bus simulation. So the one more input source is for the RBS, which means we are able to set the values is called as external data. Okay. So using this external data, we are able to get some values from the sensors, digital inputs or analog inputs. So what are the values we required? We can take the help of different kind of sensors. That values we will get it from external sources, and we have to use the same for the rest bus simulation. Okay, so that is the concept of the system variables. So the system variable acts as like one intermediate for the external data to our RBS simulation. Here you see. So external data for
RBS simulation means the RBS are remaining the simulation.
Yes.
It meant that without any data from the external. So virtually we are doing that. Without any exchange.
Yeah.
So we are getting some data that we are simulating it.
Yes, sir.
So then when you are using some external data from some sensors, is that linked to RBS?
Sir?
RBS means no usage or no
Yes, sir.
data.
Here also it is not like a ECUs. So it is like one source of data. So we triggering some values manually. So instead of that we will get the real-time data. So that is what I mentioned here.
Then it
It is not comes from the real-time ECU. So now this our Arduino it is not comes like a real-time ECU. Okay. Now we can assume for this RBS the system variable concept only I mentioned. So this Arduino CAN MCP will send us a raw message values. Okay. For example, in previously for RK, we particularly mentioned RK means ID number 120, body control model means something based on our database value. So now these values you can generate by any ID number. For example, ID number 500 or 1000, anything you can select it. Each byte you can put as a first byte for the cutoff sensor value, second byte for one potentiometer values, third byte for one digital value. So now that the values we can call as external data. Okay, so we collect some data, we can utilize the same for the rest of the simulation also. So why we are using that means upcoming this classes, which means after completion of the system variable, we will go to write for the campus scripting. Okay, so on the campus scripting, we will do different kind of scripting, which means the same scripting. We will do the values first of manual values from RBS, second from this panel simulation. Third from the external sources, which means you don't need to change it from the any argument. Once you write the code, once you dump it means, which means you write the campus scripting, you dump it to this TS monitor, we can just see the output only. For example, seatbelt configuration is there. So for the seatbelt condition is there. So the vehicle speed is there less than 20 km. If it is greater than 20 km means it is going to check the seatbelt status. So the buckle is enabled or not. So this buckle enabled or disabled means it is a 0 1 value. So one kind of input we need. So vehicle speed is there 20 or more. So one more input is needed. So that values we will trigger by the panel. So what I am saying, instead of panel, we will get it from the real-time data. Okay, you don't need to change here. So what are the values we entered in our Arduino, which means in our real-time data. So that values we will checking our campus scripting. The campus scripting only showing the warning lamp and then beeps for the seatbelt indications. which means you are not enabling the sequel, which means you are not putting the sequel properly, like that. Okay, so it is one option only, it is not a main option, one kind of option for the data. Okay, sir. It is not mandatory also. So we are having different kind of options to getting the data. So in the software in the loop, there is no need of VCU, but we can take the type of signals. So signals we can call as the different kind of sensor values, different kind of input values. So the data we can take it and we can merge it to our simulation tool, which is simulated ECU. Okay. Okay, so here we are having that three directions, which means the external sources, we can take the data and we can store some temporary variable. So the temporary variable will give the same variable to the RB signal. Or else, we will take a temporary variable and we are going to work with that signal, which we can now generate some signal values here, but we are not affecting the signal. So we just take the values and we will store it by one more variable, like variable 2 or variable 3, we can create it. The signal value we can store it here and we can do some which means scripting operations. So at that time that signal will not affect. So what are the codings we can do? The signal will not affect. We will just check by the system variable. Our feature is tested means we can apply the same to our signal. So one more option is bidirectional. So bidirectional means same time we can use the values to signal means it is taken by variable. Or else you can use the values to variable means the same value taken by the signal. So same time we are getting from any places, not mentioned from signal or variable. We can give it to any places. So that is called as a bidirectional. Now for variable to this means you definitely give the values to variable only. So that's the value only it is taken to signal. The same thing if you are giving values to signal only means it is taken to variable. But bidirectional not like that. You can give the values to variable or signal. Any places you can give it, both will be taken. Okay. So this is the three concepts we are going for the mapping. So this part is called as a symbol mapping. So this part is called as a system variables. Okay. So in our simulation part, we are having an environment. Going to simulation. We are having one point as a system variables and then system constants is nothing but what are the constants they are previously inputted. So that is the list of constants we can see here. So there are symbol mapping. So applications like system variable we will map it for the symbol mapping. So the symbol value is nothing but we will work like a transmission window. So we are having some IG blocks in our transmission window. Same like that IG block values we are able to give for the variables also. So these kind of topics we are going to cover now this session. Okay. You got some idea about the system variable? Okay. So turn off the simulation if analysis simulation turn on is just a turn off that. Go to simulation. So system variables is there. Just to open the system variables. So window will looking like user variable, type of values, last return, owner, command, this kind of things. So the system variable really gives some feel like about signal. So what we created from a CAN database signal, like the definition of signal name, length bit like that we created. So instead of that we don't have any length bit, we will set the same minimum value, maximum value, whatever we require, we will create this. Okay, it is the internal variables and the user variables. Two types of variables is there. You can see in the top part of this tab. One is the internal variable, one is the user variable. Okay, so internal variable is nothing but so in this tool they are creating some of the internal variables for storing some values. So we don't need to change the internal variables. We are all going to work with the user variables. Our required variables, user defined variables. Go to this user variables. Right click here. It is asking for create user variable from say last from the last tab. Okay, you just to open the create user variable. Now it is asking the properties of this variable. So which means the variable name. For example, we can give this for example vehicle speed. So this variable name we can set as a vehicle speed. So the category means nothing but which message you have taken like that. So now it is no needed because we are taking just a temporary variable only. Okay. So the command means so what's the purpose you have created, so that kind of command we can add it for. I can mention checking obvious vehicle speed signal. For user variable, this category command are no needed, but for confirmation we can mention it. So next is select the data type. So we are having that integer of 32, unsigned integer of 32, which means it is a bit they are mentioning. So an integer of 64, so 64 bit integers and then unsigned integer. So unsigned integer of 8 bit array, 32 bit array, 64 bit array, double array, and then string. So these kind of different kind of data types what you have seen in our programming session. So we will use that. So now we are just going to work with the integer of 32 bit. That is enough for us. Okay, integer of 32 bit. So suppose you require unit means, for example, we are checking for vehicles, so I can mention kilometer per hour. Okay. So this precision, this format specified display format, these are all needed. You can directly come to value concept. So 0 to 200 is there. 100 is there. We can take concept to 55 because the signal value is having 0 to 250. So what we record is system memory is fully for user defined only. Whatever we record, based on that we can create it. Okay. So if there is any value table mostly we are using for boolean signals only. 0 means turn off, 1 means turn on. So here no need of any value tables also. So the initial value becomes 0, current value, what is the value required? Okay. So now just you can give the OK. So now our user variable created. So we are ready to store some values on this variable as the range of 0 to 255. That's the data type of integer. Okay. Okay. So now we are going to symbol mapping. Second, choose third option from the environment. Symbol mapping is there. Just click this, it will be open. So in this top left you are having options active. Please check that active. So now the symbol mapping enabled. Okay. So right click. So on the side click on this empty space, it is asking for add system variable. Yes. So you can give the add system variable. It is directly taken to our system variable column. So what we have created now user variable. You just select the vehicle speed and then click OK. Okay. So initially, first step is going to create some temporary variable or dummy variable as per our requirement. We can set the minimum to maximum. Choose your data types and whatever requirements. Choose units, forms. You say whatever requirement you can use it. Afterwards, go to mapping. So now it is like an empty variable. We are manually giving the values also possible. For the variables, we can manually giving the values, but instead we are going to work with signal now. Okay.
So this vehicle speed is mapping to RPS signal or both ways.
Again, vehicle speeds.
You are mapping symbol.
We are not. So up to now we are not mapping. We just add the variable mapping session. So this now it is showing only red color now. So red color means it is not mapped properly. Now we are going to map it for which signal we need to store the values of this one. Okay. So now you can just click this. So once you click this, means it is asking for check value, set expression, set direction. From top you can see. So whenever you have mapped, you will be using the key of check valid. So now I can give this the error in mapping, please check log, which means we are not mapping properly. So it is the which means the expression space is for the signal value. So what are the signal required? Can or in or like that. So I can give a set expression. So in this top we are going to set expression. So select the variable. After we give the set expression. So once you view the set expression, means it is showing the x1, correct? For you all got it? Okay. So this x1 is nothing but they are using inside of internal variable x1. That internal variable going to store some signal value. So here in the left side you can see the x1 on empty column is there. The value option is there. So once you can click there, means you will get one pointer, mouse pointer. Okay. So just to open this, it is showing like on a circle phase of different kind of protocols: scan, linear, flex ray, system variable, constant, clear, delete, cancel, this kind of. So now we are going to select with the can. Okay, using the pointer to open the can. So it is taken to our database. Okay. So now you can type here as a vehicle speed. So vehicle speed you can take as a TCU vehicle speed, transmission of the vehicle speed. Okay. Got it? You can select the address of 0 CAN DVC from TCU node, TCU message, and then check the vehicle speed and then click OK.
So can you repeat this?
Yes. So initially we are all going to add our system variable or symbol mapping. So after that you just select it and right click means also. Right click it is asking for set direction, set expression also, or else you just select this and then in the top it is asking set direct or set expression. Okay. So here first I will experiment with set expression. So click set expression means automatically it is showing here one x1 and then left side column you are having the variable values also. Okay. Got it? So next in this value column you just click it means you will get the mouse pointer. So afterwards you can open and then click the CAN. Okay. So if you click the CAN means the database will be open. So this one. Okay. I will explain for that symbol mapping again. So open symbol mapping. After creation of the variable, the user variable, go to open symbol mapping. So here if it is not active means please do the active state. Afterwards you are going to this column. So here you are going to add system variable or anything else. So right click here it is asking for add system variables. You can add it. Whatever we have created our system variables. Okay. So now it is added. So it is just like a empty variable we map to get. We need to map it like a signal to system variable. So just click this and set expression. So it is showing the expression of x1. So in this x1 we have to map which values, which means what kind of signal values. So I can give here as a CAN. Vehicle speed. So I will take it from the TCU node. So that we have mentioned CAN database of TCU node from TCU message of vehicle speed. Okay. Click OK. So now you can do the check value. So once you do means all values are valid like the concept you did. So once you do the values here, you can do the check value. Okay, in the top you are having the option check value. So now it is showing all pairs are valid. Okay. So now you understand this. So this x1 is our expression. The expression we have is the signal value of vehicle speed. Now you can see the direction is moved from signal to the system variable. You can see this arrow. Fine. Now we are going to work with that signal to system variable. For example, RBS signal to system variable. This kind of direction we are in this now. Okay. So now this direction and visual display means the variable is going to signal. First we can move the signal to system variable. Okay. Now we map it on that, click OK. So parallelly I am opening that CAN RBS. Okay. Now you can start the simulation. First analysis, start the simulation. After starting the simulation, please check CAN RBS, which means CAN RBS simulation turned or not. So you can check that CAN RBS. After please activate the network of CAN Day6 from RBS. So next you can turn on the TCU node, TCU message. Now here it is showing the 0 kilometer value. For example, now the vehicle speed can give us a 100 kilometer. So now the 100 kilometer same values you can see by the variable also. Got it? Okay, once again I will explain. So after proper mapping, which means signal, which means all simple system variables are mapped, means next we move to parallel you have to open the CAN database simulation and then system variable. So first you have to start the simulation, main simulation. Afterwards you are going to rest of the simulation. Now for I am automatically started because I am enabling the auto start RBS. Okay, so that my RBS is automatically started, and parallel in the panel side also I am using a back window, so that automatically my node get activation and then my message gets activation. For this you need to manually activate this node and then manually activate the message. Okay. So after enter this, you have to give the vehicle speed value because now we map the vehicle speed value to the system variable. I can give the 120 means once you will enter the values, you put the enter. So now the values parallelly change in our system variables also. So in this case, don't forget to use the values after you press the enter key. So for example, now we are typing like 20 means after typing the 20, please use the enter key. After only the value will be reflected. Okay. So whenever we are giving any values from this folder, please don't forget to press the enter key. Okay. All of you got it? Okay, so now we are having some doubt why these variables we need to set the values. For example, now the signal already having some values. That values why we are need to give these variables. That is some of the doubts are there. Because now this variable will act like a one dummy signal, which means temporary signal. But it is not having any easy mappings from any transmitters. It is not having any message. So at that time we will not get any affected from the real-time signals. Okay, now it is working like a one vehicle speed signal. This variables act like a vehicle speed signal. So now using this system address, system variable address, we can using some scripting. At that time we will face some issues. At the writing of scripting, we will face some issues using of real-time signal or simulated signal. So that we are refer system variables. Now what are the values you give here? So this system variable act like a one temporary signal values like a vehicle speed. Okay, it is RBS2 signal. Yes, sir. RBS. So now we have worked with that RBS2 system variables. So what direction we completed?
Difference between RTS and RBS?
Or
RTS.
RTS.
If you are saying RTS, right?
RBS.
RTS. Not RTS, RBS you are saying.
RBS what I am saying.
So previously, sir, that is system variable to RBS.
No, it is the first direction we completed. Now we just completed signal to system variable. So second I will explain system variable to signal. Okay.
No, RBS.
No, I just directly go to second direction. I am not saying the first direction. So first we will get a clarification on signal variable.
Here is a variable where we can manipulate the database, the change data, the modified data of RBS.
Yes.
Can be reflected in the system. That we are using in capital.
Yes, in our capital scripting we will use this. So first we will understand the manual concept of the system variable. Afterwards we can directly map it and then we can use the values and test the scriptings. So now we are not going to write the scripting, sir. Now you can just understand the concept of these directions only. So what is the communication between this system variable to signal and signal to system variable? Okay, sir.
Why are these something directly writing a script directly we can view the variable and we can initialize items like writing SQL.
No, sir. So afterwards it is having some features also. Okay. The system variable is also able to work like IG block. So that I will explain. So step by step. So initial step is what are the easy steps I will explain the first step. So afterwards some little complicated I will take. Okay, sir.
When you have to declare the variable x1, so after that it is shown from x1 to the vehicle speed. So that we have to declare what the default it will generate the values from RDS to
So the
LP.
variable will have a resource.
Yes.
So whether it is generated by the system or we are
No. That x1 is the default thing. Yes, so after the expression is here they call as expression means x1, x2, x3 like that only they call as. So we need to set as a signal to system variable means it is the option. Okay, so it is a default. So here we work like a different kind of options also. Now it is like direct values. Instead of that we can take a RT. Okay, so because we know very well about this RT remote keyless entry. So whenever we are pressing the lock, it is checking for all the door values. Right? So which means the door values also have some signal values, FL door, R door, R door and then default door. So now these door values all are equal, which means 1 on 1 means they are all will be enabled. So in this expression place we are able to write some OR gate also. Okay, so first I will explain this mapping and afterwards we can take into the how we can use logical operators. Okay. So now the first direction we have cleared, correct? So from signal to system variable, we have cleared, which means what are the values we map from which means we take it from RPs, we will be able to see in our system variable. So is it clear? We will move to next direction.
So we are not doing anything with internal variables. We are doing
Only user variables. So next you can open the symbol mapping again. Open the symbol mapping. So now we are getting the values from signal to system variable we calculated. So I just delete this one. Delete all this. Okay. So we have here the first and second action of signal to system variable. So that I cleared all the mappings. So next we will move for that variable to signal. Okay. So first option, first direction variable to signals. So here we have the can load databases options. You have the can load database. You just click this, it will open our database. Okay. So here you can search vehicle speed. So vehicle speed you can take from TCU node. Vehicle speed you can take from TCU node. Vehicle speed signal is there. Got it? Once you can search in this search node.
So, should we delete the vehicle speed what we have generated previously?
Huh?
Vehicle speed we have generated.
Previously already we generated from user variable. So as of now we have created users and load database files. So I will explain this.
So, what is the next step we have to do? Symbol mapping.
So go so okay. I will explain. So we already mapped our vehicle speed user variable in symbol mapping we already mapped. So you just click this and then give the right click and then delete selected class or all numbers. You can delete all the parents now. Okay. Now the symbol mapping is showing like an empty column. Okay. So after go to can load database. So here it is showing your entire database. In this top, we have time filter option. You can type vehicle. So it is showing a TCU node and then TCU message vehicle speed. TCU node, TCU message, the vehicle speed is there. Just click and right click the vehicle speed. Click and then right click the vehicle speed. Please type the two options. One is a copy name, one was the auto create. Yes. So all of you got this option. Copy name and then auto create. You click on that signal only, not message. Okay. Once again I will explain. Search in the filter bar. After you it is showing like this. So you just scroll down and then it is showing the TCU node. So this TCU message is the TCU1 and then it is an vehicle speed. You just click the vehicle speed. Afterwards, right click on the same. You can get the two options copy name and then auto create. We can just give the auto create. Auto create. So now the variable automatically created. Okay. So which is means it is taken as a system variable of vehicle speed. Now the signal automatically created as a vehicle speed system variable. Okay. Once you give this, you can give OK. Okay.
This is vehicle speed is from vehicle speed. Here I choose this vehicle speed and then this.
So we already created a vehicle speed in our system variable so that we are getting vehicle speed _1. If you are not created means in case you have created a different variable name means you will not get like that. Okay.
That we have deleted.
Huh?
That we have.
Yes. Else we can go to the system variable and then we have to delete what we previously created. Okay. So this is what we previously created. I just deleted this. Now I will explain. Go to symbol mapping again. So I just deleted this. So same concept. Go to load can database. Okay. And then check vehicle speed. So showing some nodes. So particularly like a TC node, which means we are going to take the transmitter values only. So transmitter node transmitting message TC1. So you have to select the signal and then click. We are getting two options, copy name and auto bit. You just auto create it. So once you create it, automatically the values you are getting from system variables. So it is called as the auto create. We no need to create any user variable manually. Okay. So now it is created. We can give a check value. So now this dash is showing like that. So variable to signal. You can see here variable to signal. Okay. So now we can give OK. So now the values mapped. So what are the values now we are giving this user variable? It means user variable weight is squared. The same value we will get it by our base. So we just double click this variable. Double click this variable to get the current value option. This properties window getting the current value. So instead you have to change as a 200 and then click OK. So the same 200 value you have to see now are this. Got it? Once again I will explain. After the mapping, after symbol mapping, so create auto bit given means automatically it is created from variable to what are the variable? It is created the variable to signal. It is being transmitting some values. For checking confirmation, you simply check value, all paths are valid. So that move to OK and then move to the system variables. So system variables automatically one variable created. So you just double click this. So I can give as a 180. So what are the value you have mentioned? Click OK. So the same variable value we can see in our system variables. Okay.
We have to start the simulation.
Yes, you need to start the main simulation, that analysis simulation, that start RBS and then give a node and the node message. It is a formal conditions. Okay. So don't get confusing. I will explain again. Please. Okay. So now we did two type of direction, from RBS to variable also, from variable to RBS also. We did both the directions. So one more is the bidirectional values. In bidirectional, for example, now this variable value only gives the values to the RBS signal. For example, here you can set as a value of that means you will not get it from user variable. So the bidirectional values, if you are setting means you can change from here also, it will be reflected here, or also you can change from here also, it will be reflected from RBS. So that is called as a bidirectional. Okay. So before going to bidirectional, this feature also carries some IG block properties. So I will explain that after we move to bidirectional. Okay. So we are able to use IG block for this system variable also. It is like a temporary system variable. Already I said it is a temporary signal also. It is not having any mapping, but it is having signal generator options. So that we are going to the same simulation column. We are having one stimulation option. Stimulation. So in this environment column, first one is the system variable. After system variable, we are going for mapping. So afterwards, we are having symbol value. So symbol value, I will explain. First, we will come with the stimulation. So go to stimulation. Just click this. It is asking for add stimulation. Just giving this. It is open the window like stimulation. So now you are right click here. It is asking for new signal from dB. It is showing like a new signal from dB. What we have seen in our transmit window. So dB means for this one, dB is called as this system variable. You just click this. It is directly taken to our system variable. Okay. So what are the variables we have taken? You just click the vehicles now and then click OK. So here also now it is showing the same signal generated block what we have seen in our transmit window of IG block. So here you are having generated IG block there. You can give like a value range, RAM impulse, random, whatever we have. I can explain the value range. So we can use the value range, the same settings you have to follow it. The settings are here the value is maximum 255. So you have to mention 255 and then take it as alternate. So then give apply and then close. So now you have to start the signal generation. Now you started now. So it is showing the output in our system variable. So now it is mapped to signal now. So now the variable generate the value and then we can see in our vehicle speed RBS also. Got it? So now we can see the same in trace will also. Go to trace. So now it is showing the vehicle speed is running data. Correct? What the point? Okay. So we are able to work with real-time signals. So that is called as a hardware-on-the-loop simulation. We are able to simulate some signal values. That is called as a software-on-the-loop simulation. So instead of real-time hardware, we can take it from the transmit window. So that is also able to trigger some values as per the user requirements. So we are having some IG properties. That is called as a value range, random, acceptance. So the same what we did that real-time concept of transmission, we can use it for the temporary variable signal value. We can call as a temporary variable signal value, which will not affect any ECUs. Okay. So this signal, which means this temporary signal, will generate value for the RBs. Okay. So some of the features we get it from the real-time concept. So the transmission, it's like a value range, random, toggle, this kind of value. Now you get at the temporary variables here. You just accessing the values here means you get it from the RBs also. Okay. It is a one kind of feature.
You mean you don't be taking data, so we can interact with suppose we are getting external data. So if you can give some data like this, you can reduce the speed and automatically.
Yes, sir. That is what. So the internal, which means the external data. For example, the vehicle speed you mentioned, the external data you have potential to reduce the values. The same values you will store it by this variable. Afterwards, we will execute the same to RBS also. So for that we are going to write the code, which means now we created on just a temporary variable without allocating any mapping of any signal values. Okay, just created only user variable. We are now need to going for symbol mapping. Okay, so you just created on system variable dummy variable. Afterwards you are going to write the scripting. So on that we will particularly mention some message. So the message value is stored to this variable value. So after this variable will be mapped into RBS. So the external data will be stored on the some variable. The variable will be again sending the values to RBS. Okay. So that is the one next level of concept. So as of now we just understood how to be mapping from signal to system variable to signal. Okay. So the symbol value is nothing but a it is a small concept. Symbol value after okay. So the symbol value is nothing but we can manually give the particular signal values. For example, we can give the CAN signal or say we can give the flip name flex rate, so system variable. So what are the signals you need? Any one of the signal you can take it here. For example, the system variable I can take it here. The vehicle signal. Simple value, nothing but so what are the values we can manually giving? So it is like a small feature, it is not a mandatory thing. So for example, the new value we have computed as 170. So then commit new value means the new value we will be seen our 170 or user variable. So what are the mapping we did the same places we will see. Okay. So it is like a small option, it is not a mandatory thing. Okay. Simple signal we are taking from the database. Yes, database. Okay, here also we can take for variables, we have different types of options. So CAN signal, then signal, flex rate. So this kind of signal values we can take from database. Yes. So system variable means we can directly take from the system variable, user variable. Okay. So now I connected system variable. Okay. It is a small concept, not a mandatory thing. It is not having that much peak. Okay. So in this tool, they are giving different kind of options to sending the values. So we need to understand that we are able to give different kind of sources to sending some values, set some input values.
Right now, you are explaining variable to RBC. So that's why I can get variable change. That's the RBC signal. Suppose previously you explained from RBC signal to variable. That time if I am using this one, I will change the correct value of the variable.
No, it will not work. So here you are using the CAN signal means that time it will work. Okay.
Current value is not editable.
Huh?
Current value is not editable.
So simulation. Single value. So going to this top of your diagram, different kind of option, select signal. So before that, I just
New value will not be able to.
New value education, but current value education, it is not eligible.
so select signal.
ఇక్కడ మాత్రం
Then sir can answer.
are in the system variable management and also stack database it is changed. And if you keep conservative, it changes. So again you go to system variable, it will show you previous.
Once again, I will explain. Go to this single value, select signal. So here I can take the value of system variable. So using the system variable, so what we have created in that column, we got it. So I will select the vehicle spin and then click OK. So now before you have to confirm it is that simulation is connected or not. So I have to connect the simulation. So now it is showing the previous current value is nothing but what are the previous value entered.
The main question is now new value suppose you get different values. Current value is still showing conservative.
Oh. So you can have to enter the value of 200 and then give coming new value.
So they change.
Yeah, coming new value means now it is showing that 200 the current value also 2. Okay. So these are not that much important. Different kind of features they have to set the input values. Okay. Okay. So last one we are having that option as a bi-directional. Shall we move to bi-directional? So here the main concept is we are knowing different kind of features and different kind of work also. So don't forget to check that the simulation is connected and the parallel the transmitter is running or not. Suppose the transmitter also running means we will get a different kind of output. Okay. So we are working with RDS means please ensure that unless this part transmitter is turned off or not. Okay. So that are the basic configuration we need to check on it. So if you are working with only CAN RDS means check that the simulation is turned on or not, that database checked or not, and then particular mode and message is checked or not. It is in normal signal or RC signal, everything we need to check on it. Okay. Or else it will be collapse or value. So RDS also generating 10 milliseconds of message value, same time transmitter also generating 10 milliseconds of value. The same value will be transmitted by real time part also. It is also generating 10 milliseconds of value. Totally 10 plus 30 milliseconds it will be taken. So your RDS value and then model value and then transmitter value. Both the values are collapsed. You will get the 0, 1, 1, 2, 3. So different kind of 3 input values also.
But in the hardware we will connect with keep it hardware selection feature and that maybe you will take transfer.
No, at the time transmitter also will work, sir. If your matter with peak means, so peak will transmit ID number 120. Same time transmitter also able to transmit ID number 120. Same time RDS also transmit ID number 120. Because the 3 ID number is 120 only, so it is showing only ID number 120. But frames per second will be affected. So based on this 10 numbers and the 10 numbers in the system 10 numbers, the champions will add. But we are aiming for that 100 FPS, but it is showing like only 70 FPS or 60 FPS. Okay. So please ensure that before working with this kind of concept. Okay, so next one is the symbol mapping of bi-direction. Select this. So select this signal. So it is asking for the set direction in the top. Or else you just right click on the signal.
So the signal you created in the second like first you are not you went to CAN DB and then you
That is another method.
that was if I create a lot of keep it better.
That is also possible, but at the time we will face some expression issues. If we are setting the expression means we are not able to generate value from variable to system. No, it's a variable to signal.
That's why we not doing this.
Yes. So that is the way I am explaining here out of here. So initially we have manually created a user variable means we are not able to set the user variable to which one that expression. Okay. So set the direction. So it is asking for bi-directional signal to system variable, system to signal. Okay, you are getting the 3 types of options, right? So you have to set as a bi-direction. So bi-directional set.
So previously we have
We don't have that option because we are the user defined variable. At the time we will set the expression only. The signal only able to give the values as system variables. Okay. So once again I will explain. So the vehicle speed is there. You have to click and then right click. You have to set direction option. So click set direction. It is showing the three types of directions. So you have to select y direction. And then click set. So now you have to check the value. So all paths are valid. Now you have to give OK. So now you have to see here. So in this vehicle speed value I have mentioned as 120 here. So now the same 120 value we have to see in our vehicle speed of the RB signal. So in this RB signal you have to set as 50. So the same 50 value we have to see in our user variable. You have to check on both inputs. First you have to give the value in our user variable. So that value we have to reflect in our RB signal. So after got it, we have to check with RB signal. So RB signal value you have to change. The same value you have to see in our user variable. Okay. I don't have any peak USB, but you all have the USB systems. So yesterday we did some programming on that kit also. One transmitter, one receiver. Based on the transmitter values, it will be responsive by RK 1 or 0 like that. Okay. So now the same value going to we are receiving in the trace window. So first step is we are going to this hardware. Please connect any of the system by the hardware device or peak. Please connect the USB from any of your device. So then select the peak CAN channel or CD. So I don't have any peak device. So I just give the total explanation. I don't want to start coding. Assume don't know any coding because yesterday you have done some coding on the kit. So that now it is already working. You just check the power is turned on. The kit power supply is turned on or not. Okay. Please ensure that your kit has that power supply. So please turn on the power supply and then goes to connect the peak USB to your system port, and then you will get the power as a peak CAN system of 82. I don't know the system. You just connect the peak USB. After set the channel mapping. Go to analysis and then turn on the simulation. So you will get the trace window of the two IDs, which means one is RKE, one is a body control module. Two IDs you are able to receive it as per our yesterday code. Yes? Okay. So now our concept is we need to set the values to our RPS. So parallelly you people sir please open that RPS.
Shall we go to transmitter?
No, you don't need to transfer anything. Automatically, all the values will get it by place window. With the help of our yesterday's coding, we download the system. Okay. So go to simulation and then CAN RBS. You just turn down the simulation also. Now you can see where the log signal is there. Which means it is available in our RKE ECU, right? RKE ECU, right? So in this RKE ECU, the value only showed or not? I think you are not getting the value. So in this RKE you are getting only 0, right? Okay. So now our work is we are going to get the external values and store it by one temporary variable. That variable is going to store the same or RKE. So that is our concept. So in the previously we created variables and we manually setting some values for the variables by stimulation. Then manually we have to do the user of symbol value, and then manually we can do the current values. Okay. So instead of that, go into the system symbol mapping. So directly you can open the symbol mapping. So please active. So if it is active, means open the CAN load database. CAN load database. Now you have to type log. So search log in our filter session. So open the RKE ECU. So RKE ECU of TX message of TX of RKE message, you are having the log, correct? So same concept, right click and then give the auto page. So after doing this, you are getting like a system variable to which means a signal. but we want a signal to system variable, correct? So just you have to mention, right click, set direction as a from signal to system variable you have to mention. From signal to system variable you have to mention because the external signal only sending the values here. Okay. So now we have got directed from signal to system variable. Now click OK. Now parallelly you have to open the system variables. So now it is showing the log value as a 1 or 0 based on your user input. Okay. Got it? In this log place because I am not able to get it, I am not able to
Peak here.
yes. So whoever having that peak device, whoever connected with the peak device with the PC, he is only able to see it.
0.
So, okay. So you will receive the value of 1 or 0 based on your user input. Or else yesterday you stored on code, correct? From RKE and the PCM. So finally open the Arduino off and dump the same code with the different value. For lock as 0, unlock as 1 like that.
Yesterday you lost as 1 0. Now you are getting yesterday you give 1 of 1.
Got it.
So you
So
are getting
finally open your Arduino code. So from right side you can open it. Right code.
right code.
Right code is enough. No need of read and write. Only right code is enough. So here I am using the sample example, but you have to open modified code what you wrote in the studies. Right side. So please come to the code and same ECU. It should same and not want to change the ECU because that receiver will be perfect. Okay. Right code like the message ID is 120 means. For now we are just getting only log, so that I mentioned here you have mentioned as a 1 or 0. One or 0, okay? Here. So one window you have to open as the Arduino code. So this Arduino you need to dump on the right side of your transmitter window, which means right side of the ECU, which means Arduino code. So after dumping the value is 1 means in this simple number, which means the system variable also we need to get output as a 1. If you are sending the value as a 0, the log place we need to get output as a 0. Okay, so this is the concept now.
చేస్తే వస్తుంది చేస్తే రావాలి
There is no relation.
So that we are directly mentioned as a this but we are using the external data now, so that the external data stored on this one. So after this value I can take it and then show it to the software in the help of coding. It is not a direct mapping.
Okay, I think you are now receiving the log value of 1, 0, so this kind of values we are receiving. So now our task is that from the system variable to, so our task is from system variable to RBase is the task. so that we need to write the code for it. So previously we are not working with any external data, so we got the possibilities from system variable to signal, signal to system variable, both bidirectional accessing. So for the system variable accessing, we are having signal generator block also, like random samples, this kind of option we use. Everything for without order simulating purposes. Okay. So now we are working with assuming that we are working with the sensor service, real-time sensor service. We have to take the sensor value by raw message. Or any other database values we can use it. Afterwards, you have to convert these values, which means transferring the values from here to always with the help of scripting only. Okay. So now we are not strong to how to get the values from the variable from digital scripting, that is fine. So after we enter the capital scripting, we will get the values from, which means using some get values, set values like that. We are using get the values and set the signal to it. Okay. Now up to now it is fine. Now we are able to receive the external data also. That is the concept. Got it? Okay. Okay. So now here I am going to explain about the concept of expression in symbol mapping. So okay, now you have to connect a card as a virtual device. That is enough. So for external source data, we are able to get it now. So that concept is understood. Yes. So there is no need of any external hardware. You have to work with the channel selection of virtual devices. You change your channel selections of virtual devices. Okay.
So where is it?
So hardware, going to hardware.
So we have to this to be is connected.
Disconnect. Now going to disconnect it.
So it's not getting.
No needs. But now we know how to get the external data. That is it. Go to hardware channel section. You have to check this a virtual device. Okay. Okay. So here I am going to check on create new variable. I am deleting these all variables. I selected delete selected all system. So here I deleted all the system variables. Okay. So just to create one empty variable, which means create user variable. For us, you can give the name as do underscore status. Okay. So maximum value I can take as a 0. We can work like a 0 ones. Okay. And then we click OK. That is right. We are creating a user variable door status, so the minimum 0, maximum 1.
Create
Now create user variable. Right click, create user variable options there. You have to use that and then give the name as a door status, minimum is 0, maximum is 1. So after creating this, you go to symbol mapping in our simulation. Symbol mapping. Open symbol mapping. So previously the mapped variables are there. You just select it and delete it. Okay. So now right click. You have to add system variable. Okay. Add system variable. So use that door status. And then click OK. So here we are able to set the expressions only. F of x expressions. So right click, you have to set as a set expression. So not direct expression. So after setting the expression, it is showing the x1. So here in this structure we are having x1 now. We are able to add x2, x3, x4, x5. So what are the values we need? We have to add it here. Can signal, in signal, anything. So here I can take the 4 values. 4 x1 values. So first one, we just click the value, it is showing the mouse pointer open, and then open to can.
you have to be signal now.
Yes.
That's
You just select the door. You can type door. Type door. So it is transmitted by body control model EC. Okay. So it is having we are having 4 switch values. FR door, RL door, FR door, RR door. Okay, 4 door switch values are there. Just click and open it. So for each X1 for X1 as a FR door, X2 as a FR door. Like that, different door switches you have to navigate. You have to. So go to this symbol mapping, right click and add the water system variable created, map door status. Afterwards, right click and then set as a set expression. So once you give the set expression, it is showing the left side of variable and then type of values also. Here we have the possibilities to add different kind of expressions also using the plus symbol for x1, x2, x3, x4, x5, x6. So now as per my requirement, you have to create 4 expressions. Okay. So using the plus symbol for 4 expressions and then going to click the value, it is showing the mouse pointer. Sir, transmitter. Go to the scanner, you just search it for door. Here you have to search it for door. So in this node we are having a body control module because this door switch is available in our body control module only. So that I am mentioning the body control module as a transmitter is new. And we said Day6 70. So you have to select 4 door switches for 4 different values. First one FR door and then click OK. So and then second FR door, third R door, fourth RR door. 4 different kind of doors you have to select here. Okay. Okay. As of now, all of you selected the expressions values. Next person. Okay. So next step is why I am adding this 4 expressions. Now we are going to check this only common status is a door status. So now we can take the real-time example of RKE, remote keyless entry. Whenever we are pressing the lock values, it is checking 4 doors. So when it is working means 4 doors are closed or not. So 4 doors are closed means we are using AND gate. So door value 1. So next door value 1. So all the door values are 1 means the final outputs the doors are locked. So using the logic operator here. So in this expression column we are having x1 now. So you have to type manually x1 using the AND gate, single AND you can use. Okay. In this top expression is there. x1 AND gate, again type x2 AND gate, x3 AND gate, x4. Got it? x1 AND gate of x2 AND gate of x3 AND gate of x4. Manually you need to type it using the small x. So what's the variable name they are having? The small x you have to type x1 AND gate of x2 AND gate of x3 AND gate of x4. So in our C program we are using a double AND for logic and here do not like that we are using only single AND. Sir? Got it? So once you enter, click enter. So now it is showing the red color now. You can use the check valid point. So after you check valid, it is showing all transfer value. In the top you are having one checkbox as a check valid. So once you type this, you have to click this mark transfer value. So here one question mark is there. This expression is there plus and minus one question mark symbol is there. So that is the help for the expressions here. Which means what are the expressions we are able to add in the expression column. x1 multiplication of 3 plus x2. So how we are able to use this expression? They are giving some expressions columns. Okay. So this kind of the expression we are able to use here. Then click OK. So now what we are set this variable means. So this door status value will be checked based on the signal value of 4 door switches. So whenever it is giving all the four rows which is value 1, at the time only the dose status value will be 1. Okay. So as of now this mapping is fine. Okay. So now we have to click OK. Start the simulation. Start the main simulation. So under go to that simulation. Parallel open the system variable and then look for rest of the simulation. So you have to go for the body control module. So body control module BCM.
RKE we can answer it, sir.
Sir?
RKE we can answer it.
Yes, that is not an issue. You can answer it. Okay, so when we are giving 4 dose which is as a 1, after that only you will get the output as a 1 here. If you are setting the value, if any of the those the value is 0 means, you can see automatically the value changes is 0. So for that, open the rest-based simulation, connect the main rest-based simulation, please check the database is active or not. So previously you opened any other topics also, you can deselect it, that is not an issue. Just turn on the BCM node and then BCM message. The last 4 are those which values. So 4 data you have to enter as a 1. At the time only the dose status will be 1. Now we have triggered the event. So here the event stands for like timers. Okay. So here the event stands for this variable as an event, timers as an event, on can on as an event, tx as an event, on can pre-tx as an event, and we are telling that last as a start event, stop event, on timer, on variable change. So these are all called as an event. So okay. So this event comes under the basis of tx event, rx event, timers, variables, start and stop. So what we discussed about in the CAN protocol. So the CAN protocol is on communication access from one ECU to another ECU. So at the same time we are able to receive by the same user and the same ECU able to transmit the values also. So this is the concept of CAN controller, which is controller area network. So here the transmission part is the event. As a programming event, we can call as a transmitter as an event, receiver as an event. So we are going to set some timing. So message time interval or message cycling time. So these timers are called as a timer event. So on the variable event means nothing but what we create in the system variables for a dummy variable act like a dummy signal. Same like that, in the coding also we are able to create some signal. Create some dummy variables. It will be act as a dummy signals also. So on the next one, stop and stop event. So whenever we are going to we are having some options in the scripting, one start and then one stop. So the start time of the scripting, what are the necessaries we need to do. So the stop time, what are necessaries we need to do. These are the event only we are focusing here. So the type of scripting is a fully event based programming. Okay. So this is the major key point of this capital scripting. So I will explain by this step. So this program box, this lecture we are having on program box in the source code editor. So please all of you open CMD script. Go to design, go to new CMD program. The first one you are trying add C code editor. You open it means you will get the result like this. Okay. So here we are having the source code editor. These are all comes under the tools configuration, which means what are the inbuilt code they are carrying, what are the interface they are carrying, what are the database interface they are carrying. So these are all common for only this tool, not all capital scripting. So for common for all starts from the variables. From after documentation, you can see variables, timers, onCan, RX, TX, PTX. So as well as the same for the different protocols also. In let's say Ethernet, TCP. So these kind of protocols also having the same kind of thing. Now we are focusing only CAN. Okay. So if you are entered the tab scripting as any tool, the common is variables, timers for CAN, RX, for particular CAN protocol, CAN, RX, TX, and then CAN 3 TX is some additional feature in this tool, but common is a RX and then TX is enough. Okay. So the last thing is a on timer, on variable change, on start, on stop. So these are common in any tool for the CAN scripting. Okay. Okay. So before going to that, it is having some functions. So in the top left, we are having symbols, functions, and then properties is there. Please open the functions. So once you open it, it is showing like app, com, test. Afterwards, it's showing our messages of our database. Yes. So this app, com, test means nothing but app stands for application, com stands for communication, test stands for test. Okay. So what it is having means just drop on the app only. It is having different kind of functions like nearly so commonly you can say app, com, test. Nearly these are having above 300 functions. It is having. So entirely for automate this entire tool. These functions will help to automate the entire tool. Once you write the entire code, which means you can code these functions. You write the code here, you just start it, means that is enough. So this coding will automate the entire tool. So that is the purpose. This tool having different kind of features. But in campus scripting not exactly. So I am just focusing only campus scripting. Okay. So for the campus is a communication access programming language. So you just drop out and then go for the COM. COM means communication. So these are common functions now in entire campus scripting. Okay. So these are common for our entire campus scripting. So just drop on the COM. It is for example first one. It is having add cyclic message CAN is there. You just click this in this right side. It is opening the API documents. Just drop.
API is the
Sir?
API.
So API is the applications documents, application installers like that they will mention. Okay. So just you have to say just click add CAN cycle message means it is showing the basic definition of this function. Why they have done this function? So in this definition function description they mention send specific CAN message. So send the specific CAN message periodically or update already sent messages. It means scheduler CAN messages. So here you see, I just copy this code. This code enough code I just copy. Okay. So this is the code we are having a description. I just will explain what is this. So this T can mention as the transmit CAN message. So it is having an inbuilt header file. We are getting the TS master tool. So after the T is act as a variable, which means we are going to transmit the CAN message as we can take any variable. Okay. Like our structures we see in our Arduino programming. So structure of CAN frame of CAN message you define there. So on the CAN message dot ID number, CAN ID, CAN message dot DLC, what you want to mention, same thing. So the T dot they are having initialized with the standardized ID, which means they are mentioning a int underscore w underscore standard ID, which means initialized with the standard ID. So standard ID is 123, so comma it mentioned as a DLC. Okay, so for example, it is not an exact message. For example, they mention so create a CAN message here, raw CAN message. So the CAN message is going to transcript it so that they are taking some any other variable. So instead of T, you can take any variable. For example, you can give us a yes means here you change as a yes dot. Okay, like that. So the ID number is created. So this is the command line only. Just ignore it. So they mentioned if 0 is equal to com dot add cyclic message underscore can ampersand of t comma 5. So this line mentioned that it is going to communicate it. Communication of send the cyclic message of can. So the can ID is taken from the address of t. So the address of t mentioned the ID number 123 DLCS 8. So this 5 mentioned as a periodic time. So 5 milliseconds once you have to transmit the message. So previously you write the code on Arduino and then using delay 100 milliseconds. So that previously you were using transmission window. So on that periodically you mentioned the 10 ms. So instead of that 2, you are creating one scripting. So in this scripting you can say you can take the address of t. The address of t you mentioned as ID number 123, the DLC is 8 DLC. So you have to send the 5 milliseconds once you need to send it again and again. So this is the line I mentioned. So this line is nothing but we have to give the data. The f data of 0 means nothing but in our can program we are using can data of 0, can data of 1, which means first byte, second byte, third byte. Okay. So the key means mentioned as ID number 123. ID number 123 DLC of 80. You can take the first byte value which is 0x34. So after sending this value using the same line. So sending the modified data for again sending the ID number of 123 and then sending the value of 5 ms once. Okay. So these are the inbuilt codes they are coming. We just modify it. That is enough. Okay. So we don't want to go directly this entire can. I will explain the short, easiest examples. For communication purpose, I mentioned this demo. Okay. So instead of that, I will start from start. So this website you just scroll it. First one that on start is there. Okay. On start. So here you do right click. So it is asking for two pop-up. One is add on start and delete. You can give add on start. It is asking for a new start name. So you can give any name. You can directly give the update. Not in app. Going to symbols. So going to symbols and then scroll last. The last one you are having on start. So you just click on start, right click. It is asking for add on start, delete. Okay, so you can just give add on start. It is asking for common name. You just give update. Okay. Okay. So in this, just click the on start. It is showing only one items, correct? It is showing only one items. Yes. So now you just click on start. Now you are going to this right side tab. It is showing on green color sub items. Yes.
Which one you want?
Click on start.
Yes.
Yes, click on start. Okay. So now you just place the cursor here. If you are type anything means you do not type it. Just write in this. You just place the cursor inside it. So you will not type anything. So now you just click on new on start one. New on start, which means sub item. Just click it, and now here you can type it. It will be shared. Yeah.
So for any program, this is the first step.
Yes, it is the first step. For our campus routing, this is the first step. We need to view something on start. Okay. Sir. Step based in our campus routing, we can start with the start event. Okay. So what are the codes you have written here in this on start event? So whenever you are pressing this the start button, in the top you are having start button, play button is there. So what are the codes we write here? So whenever you press this button, the codes will be executing. Okay. So next you are having the one is on stop. Yes. Now you know we will get anything for on stop. But what are the codes we have written in this on stop? Whenever you are pressing this button for on stop, at the time that code will be executed. Okay. So this is the concept of on stop and on stop, how it will be working. For example, I can explain that. Now all of our analysis system is not turned off, correct? The simulation will be turned off. Now we are going to turn on this with the help of program. Okay, so all of you go to this on new on start, the sub item. Just type app app.p app.conn. You just type app.conn. You got the code completion is correct. App.app.connection. So instead of connection, you just mention COWN. You get the code completion. You just click this. Double click means it will be enabled. After choosing open and then close brackets using the semicolons. As per the same C format only. So what are the lines you have written here? So just finish with the end of the statement like a semicolon. Okay. So here everything is a inbuilt function only. So definitely we need to use the open and then close brackets. Okay. We are now going to work with a custom library. Custom library also possibility is there. What are libraries we need? We can create a custom function. But now we are having more inbuilt function. That is more than enough for our testing purposes and then some of the simulation purposes. Okay. So I have got connect. So this time mention that. So you run the script means automatically the connection and between simulation will turn on. Okay. So before going to that, here we are having three options on compile, starter and then starter. So before going to just give a compile source.
Analysis.
No, not analysis. No scripting. It's scripting program. We are having that compile box. So you just click it and it is going to compile. After compile success, it will be given. So after compile,
This I have.
showing that what we face the issues there.
Service say to party.
So here you have to see in our browser file, we have done the data for the compilers. So it is having two types of compilers, 86-bit and then 64-bit. So in this bin, which means in this export file, they are including mostly all the files are included in the basic version of 64. So this .h is nothing but our getter files. So all the getter files are included, but I am not sure that the 86 not getting everything. So that we are facing some issues on the files cache included database. Because this 64 is common, which means the initial owners they releasing the 64, but the 86 they released them before 5 months. So that as of my knowledge, the 86 is fully not updated for the compilers.
But do you put them in users?
Yes, sir.
Software is
Software is same, sir, but software was not updating that check updates you control tool updates. So and then my laptop configuration is only 8 GB. Okay. So based on that system configurations also that
we have to work on 64.
yes, 64 is common. So that is suitable for all PCs and then our laptops. So basic configuration devices it will be taken. So I am using just business laptop so that I am not facing any issues there. But systems are having more high level configurations. So that based on that it will be executed. So here I don't have network connection, so I am not checking this is updated or not. Okay. So all of you open that 64 now. So on the back end you can download for doing the update. It means update for that tool. Okay. So that will be updated.
So you want us to do 86?
86 as in your laptop 86 is okay. So
You can use it.
86.
You use this for that.
Yeah,
86 years work at the systems updates.
okay, shall we start? So in this on starter, we are giving this subsystem of new on starter. So this is the function line for connecting the application. So initially the analysis tab is on disconnection mode. So I just compile this line. So is there any error found? So because here the compile system is very very important because based on this getter files only it is to be executed. If you found any error, it is showing on this place. Okay. So now it is a compile success. You can give the start script. So now automatically that the application connected. So whenever we stop this, we want to disconnect this. So that I am saying, so open one more, go to on stop, right click, add on stop. Okay. So in this add on stop, just click this and then type app dot disconnect After disconnect the function will show here, you just click the enter button and then open those plugins. Okay. So now you have to compile this. So whenever you start the script, so automatically simulation will be turned on. So whenever you start the script, the simulation will be turned on automatically. So before going to editing session, so in our capital scripting that script is running means, so please ensure that the script is stopped or not, because now if you are typing or editing anything means it will not work. So before going to editing session in the script, please stop the script here. Okay. Just stop the script. Afterwards go on stop, right click. Go to on stop, right click, add on stop, and then click this new on stop. Type app.disconnect or app.disconnect. You can type it, you will get the completion using the enter button, using open close brackets, semicolon.
So it is having number of stop, this program will start, and the which program you are cited, all the program should be discussed.
They should be separate to start from this.
In the sound stop, the same you are sound stop. No.
Just understand how we can handle it. Yeah, we started now. No, it's not the system. It's not the sector. We start the duration of giving the stop. At the time of stop,
So we need to have some of the we adding this on stop, what are the functions you mentioned here? So now if you clicking this button, then this code will be executed. So it is not right for create only one thing, you are not able to create more new stops also. So based on the event you work, this event you have to create for only application time. So next event you have to connect only some of the messages starting like that. Okay. So the difference is this start function, which means this start event will execute only one time, like our void setup in Arduino coding. So in our Arduino coding, there is a void setup. So the code will execute only one time whenever we done. Same like that, the sound start and on stop will execute only one time whenever we are checking with this on start and then stop. So what are the codes we have to write? It will be execute only one time. So for example, here we are using printf. This programming we are using printf for printing some statement. Instead of that, here we are using log, L-O-G. So these are all keywords. So what are the keywords we have typed? Here it is showing blue color. That is an indication for us. Okay. So log, now you have to open the same console, open brackets and double quotes. We have to type application is connected with got this? So using the instead of printf save or println, you have to use the log. So in this double quotes, what are the statements you have to mention that it will be printing in our messages column. So I just mention application is connected by capital. Okay. So where we have to say means using the messages. This messages column is there. This analysis for messages are on the top left. We are going start to stop and then one message, small message symbol is there. You just open that also. Perfect. Okay. Now we just compile the script. So whatever we have to take this, it will be showing now message. I just clear the message box now. This is empty. We are just starting the script. Run the script. So compile success application connected. It is showing the application is connected by cap. So it is showing the code of 4614, which are the coordinated code. C code of 4614. So the value we are getting from the on start of new on start one. So this on start of new on start one subdivisions. So the output is the application is connected by the So, correct sir. So go to this top instead of filter we are using only log. So these are inbuilt keywords for the DS master code. Okay. So using the log, using the double quotes, the order statements in the right, it will be printed on our printf statement. Here we don't need to use any slash and any slash, we don't need to.
Will not work. Slash.
No need of any sequence of sequence like slash and slash is used. No need. So whatever you have entered with next line, it will be entered as next line. For example, so we have entered as two text. Start this with capital and capital 1 2 3 I have to do. Just run this bit. So it so there is no need of any slash and you just type the next line automatically it come to the next statement of okay. Sir,
Log is something.
a log is like a printf statement, sir.
It should be like application is correct. Statement is not there.
Sir,
This is
Last line.
master. This is compiler. This is study vendors.
This is what?
okay. So there is no need of any slash p, any slash n. So that much in depth of C don't want. Here we just using the C syntax, basics of C syntax, working with equals or such case, that is more than enough. Okay. So now we understood the concept of the on stop period and then on stop period. Yeah. So this on start and then on stop will be executed only one time. Okay. So I just stop the script. I just cut the line. Okay, I just cut the line and then move forward to the step function. In the top, you have an option step function. So the simple side, this on stop is written now. Just to scroll up from top onwards, fifth one or sixth one. So step function is there. You just click it, the right side on column will be open. So this one. So click this means it is showing like a void step or void. Okay. So here we have to paste it.
Here it's simple, sir.
So in the code script, going to this code script, this symbol is the stop plus the symbol is there. So where you created this on start, just scroll up. So in this on start, you just scroll up. The step function is there. Here you just paste it and start the script now. Now parallelly you have to open the it is continuously running. You have to see it is continuously running. Yes, it's step function. You have to paste the line, statement line.
Main step function.
And it's a step function.
Only functions will be the
It is not an exact one. It is on future instead of that, first we understand the step function means you are using the same concept for tags. how we can set the timers and call the functions. So it is like just understanding what it is. Okay. So now
Interval of 5 milliseconds.
yes.
You can change the time.
Yes. Okay. So first we need to understand the difference between this on stop, and then step function. So whatever code you write in this on stop, it will be executed only once. But in the step function is working like a timer. So here you have to see this will be worked on each 5 seconds. So instead of that, we have to change the values. Open the scripter, stop the scripting. Okay. Just right click on the step function. Just right click on the step function. You got an option say edit selector. Open edit selector. It is asking for the time interval. So it is showing some of the time interval. Here I have to mention as 1000 milliseconds. So 1000 is nothing but for 1 second. 1 second once the code will be executed. Now we said that here you have to see the interval as 1000 milliseconds. Yeah. Okay. Now you run the script. So now the code is executed 1 second, so 1 second, so. So whatever code you are writing, the 100 times codes, 200 times codes in this loop, it will be executed within 1 second. Okay. So now this is the difference between the one timer loop concept and then on start and then on start. But we are not exactly working with timers. It is the future to understanding the concept of timers in Day6 master tool. This step function will not available in capital scripting. This step function will not available in the capital scripting. Now you understand the difference between the time, how the codes are executed like that. But we need to set the time in our timers column. This left tree or time the variables timers is there now. After step function documentation is there, next variables timers is there. So this is the major timer for the capital scripting. This capital scripting will start from variables only. So apart from these are Day6 master additional features. Okay, so don't aim this is a real-time capital. So whatever we have worked from these variables to this shortcut, that is the actual capital. So from apart from this, there are the additional feature in our Day6 master tool. Okay. So now this code is working by 1 second once whatever the timing we provided based on that it will be executed. Just to stop it. Okay. Now we can move to timers. I will explain what is meant by timers. Okay.
So since the function is like all functions in parallel.
Yes. So if you want to check with any cross signal or response, we can add it in the step function. Parallel timers also will run.
So you not program function.
Not
more step functions.
No. There are different kind of step functions. We have only one step functions there.
And then what
We want. Okay. I just remove this line here. Okay. So next one is the timers. So first we understand the concept of timers. So right click this timer. So the top left you have to see variables after timers is there. Just right click. It is asking for add timer. So here we need to set the timer value as whatever we require. I have to mention as 1000. Okay. For our eyesight understanding, I have to mention as 1000. Click apply. So now we have created a timer and it is called as a timer variable. So new timer one is called as a timer variable. So whatever we have created, we can call as a timer variable, normal variable, on stop table, on stop view. So now we created the variables, but in this line it is just a command line. We are not able to write any program here. So we need to call the timer. So for that we are having at the bottom we are having on timer. Okay, it is a timer event. So on timer is a timer event. So in the top, the timer is called as a creation of timer variable. This is a timer variable. So it is the on timer event. Okay. So for easy thing, if you want to identify event means that before they mention as a on. On can or on can be. So these error they are using on, they are called as a event. Okay. So on variable change means that is a variable event. So on variable event, on timer event. So on start event, on stop event, on transmit event, on receiving event, like that. Okay. So now go to this on timer. Right click here. It is asking for add on timer. So this is showing the timer name. You just drop on the timer name. So whatever time this video created in the timer column, it will be showing here. Okay, you just merge it here. Your new timer you have to mod it. Okay, got it. And then give apply. So here we are able to write any program. For example, new timer is there. Here we are able to write any program. So here I am just pasting that.
On timer we do the right click. It should name as well as the timer name.
Yes sir.
On timer.
Right click.
Right click. Name or
This is the name for event, like new start one, new stop one, like that.
okay.
But we need
Timer
to,
we created the
yes. So for this event, we are calling the variable name of new timer one. Okay, so this variable will be having the timer value of 1000 milliseconds.
So first one we have to create variable and then we go to the event.
Yes. So initially we need to create variables as a particular time range. So that variable carrying the time range we are calling it to the event basis. Okay. So in this application, this new on timer one, I just paste to the same log values. Okay. So now I just explained it with only printf statements only, but we are just working with all the can messages. So understanding of event I have explained with this printf statements. Okay.
So in on time we have to place.
Yes, on timer you just place the log event. In this step function you just remove it, or else you get the confusion. In step function you just remove it using the control X, and then you have to paste the same one new timer. Okay. Okay, so now we created the timer variable and we made the timer variable with timer event, but we need to start the timer also. Okay, so that is having a, we need to work with the on start. Okay, go to on start.
On start.
Go to on start. So already we connected our application. So afterwards you have to write a line like the variable name you just copy the stars, you type it N capital new T capital timer 1. So what are the variable name you have created in the top row, the variable name you need to write it here. So that is a new timer 1. N as a capital, T as a capital and 1. Don't using any space. Okay. So once you type the correct name means it is showing like a blue color indication. After using dot, dot means it is asking for a different kind of function. Start to stop to set control here. Okay. We need to use the start. Start. So after that start, using the open brackets and the close bracket, and using the semicolon. So now you just understand the concept of this coding here. Initially we have created a new timer at the. So once again,
On start.
on start, open on start. On the on start we have a sub item of new on start. Okay, so on that you have to write the line, second line. Already you write the code for other times. So in this here also we are able to write any code. Okay, there is no restrictions. So I just mentioned to type the type variable name. Type new timer N capital U W T timer 1. Okay, once you type the correct variable name whatever you have created, it will be showing like a blue color indications. After using the dot symbol. After using dot symbol, it is showing a start to stop everything. You have to mention the start here. Okay. And then using open and then close the brackets using semicolon. So in the event we have created one timer variable as 1000 milliseconds. We provided some values of this event of timers. This timer event we provided some values, but whenever we started the timer, at the time it will be executed. Okay. So after the completion of the scripting, we need to stop it. Okay. So go to on stop. This on stop, new on stop is there. Type the same one, new timer 1 dot. Instead of start, we have to use stop function. Okay.
start the script is here we start this.
Because we can also say the same thing.
Step like half decide half we can do that. You start the script, half we will not decide. It's giving start and the start to starting these ones are going to be.
So what is the use of writing these log functions in on timer?
That's what I will explain. So now, someone we just try to go to the next step. So these are the steps we follow now. We integrate to timer variable for what are the timer step. So then we need to add a timer with our timer event. So third onwards we need to start the timer variable. Fourth onwards we need to start the timer variable. Okay. So whatever code in this tool, not only in this tool or in this capacity, whatever code we write for the connection, we need to give the disconnection also. So that is the mandatory thing.
If we are starting with timer, one will start there. You know when we will start the script, we are telling the app has to start. And you know it won't start.
Won't display sir, but in the back end it is running now.
After app is disconnected, it will run.
After the app is disconnected, it will not run. That is sure.
Suppose we won't be an app disconnect, it will run.
So that it's a common standard terms. Whatever we have connected, we need to definitely disconnect it. Or else suppose because all the values are flash values. Now you didn't you turn on the RBS, but you are not turn off. But you turn off the simulation, it is a turn off. But the nodes and the message will not turn off it. So whenever you connect it automatically, the last flash values will be getting the values.
Because it is automatically better.
Yes. Okay. So now we write the program for the new timer. So you just compile this and run the script. You have to see the message window here. The same output we have to get it for the 1 second once. So this is what we need for the capital scripting. So what we did the same in previously step function, we did the same in the timer set. But step function we no need for this kind of start to stop, these are no need. But in this timers we need to create this kind of things. Timer variable, set time interval, and then start the timer, and then stop the timer. So these are the mandatory things we need to follow for the timers. Got it? Got a proper output? Yes. Okay, so next one is so now we know how to write some values like start means it will be executed on time, timers means whatever we require, we will write it. So now we have 3 types of options here. One is application, one is the communication, one more is the test. So the test functions mostly we are used for test case writing purposes. Communication is used for our simulation purposes. The obvious values will be we are able to simulate by the communication. In this functions column, we are having 3 options. One is the test case purposes. The communication is for accessing R-based communication. So the application is for the system variables and accessing the automation of entire tool. So this comes under the application. So using these application functions, we are able to map in the hardware also. We are able to create the channel IDs, which means channel count also, channel mappings, add the database, and what are the database having it, everything you will see here. Okay. So first I will move with the communication. Okay. Before go with the explain system variable. So that is the thing. So in this application only we are having the access of system variable. Okay. So which means previously I have mentioned that what are the variables we taken from the external source we are storing on the user variables. now we are going to write the code for get the user variable values now. Okay. So in this open the application, just type in this filter is there. Just type SOS system. System means it is showing the different things like get system function counter and then set system. Different kind of is there. You just scroll on it. So on that I'm just explain the get system variable. Yes, get system variable into 32. So you just search on it. Get system variable into 32 is there. So which means this function is called to get the system variable value of integer of 32 and what are the variable you mentioned, the value will be getting. Okay. Just scroll. It is carrying the API documents. You just select this means you find the API documents. Yes. So the description is get integer 32 type of system variable values. So before that, in the simulation system variables, yeah, we can do those steps.
We don't have anything, so we have.
Yes. If you don't have a system variables, just go to system variable, right click, use the create user variable. You can just try by variable 0. That is enough. Okay.
Values.
Values by default 0 to 100 it is taken. Okay. So go to system variables. So and then right click here and take user variable. I think the application. Okay. So already you have created means not an issue, or else you can just create the variable 0 and then what are the basic values required. Okay. So here it is showing the description of get the integer of type of the system value. So in this bottom it is showing the examples. We are going to work with this function only. So you just copy paste two lines. Just to copy. Now we are going to paste this on timer variable. Sorry, timer event. On timer event you have already created, correct? So this on timer, you delete the log value and just paste this value. In this on timer, you are already using some log value. Delete the log value and just paste this example. Okay. Okay. Again, you have to select the function. Say it is showing the API function of this system. Gets the integer of the type of system variable value. So here they explain what is the parameters they are using here. Okay, we need to understand the functions like this concept only. So first you have to copy paste the functions here. Okay. Afterwards you go for the parameters. It is using the data type of character pointer. Okay. So it is having the complete name of the system variable with the category name. Correct? So in this place, in this double quotes, you see the example, it is asking for category 1 dot variable 1. So in this double quotes, you need to place the address of the system variable. So how can we get means? Go to system variables. Okay. Go to system variables. So whatever variable you have created, just click and right click there. It is asking for copy full name. Just give the copy full name and place it on the double quotes. Okay. Once again I will explain. So go to this example, copy and paste the example. So we need to follow the parameters what they have included in the data field. So the first parameter they mentioned complete name. So which means complete name means they mentioned as a complete name of system variable with the category name. Okay. So then go to system variables. So for example, double click I open it. So name is variable 0, but category name we are not mentioned here, correct? So that we are not getting any category name. Suppose we are mentioning any category name. Whenever you are working with the autocorrector, it is directly taken from category name, which means message number. Sorry, message value like EC_1. Like that the category name will be taken. So we don't want to get the confusion. So that this kind of option is right click, copy full name. So whatever the name is there, it is automatically created. Copy full name and the paste it under double quotes. So that is the parameter they pass in the double quotes. Okay. So afterwards it is asking for the value into 32 of system variable, which means it is a 32 bit. Okay, integer of 32 bit. So like here the integer of 32 bit they mentioned as a S32. In this example you have to see first one S32. So S32 is called as the integer of 32. In C program we are using I and T. So instead of we are using S. Yes. So here what are the variables we have used? The same variable we need to pass that as also. If you are using the variable as a means we need to store as the address of A. So now this function what function means application of get the system variable integer of 32 bit variables. The system variable name is a variable 0. So the value is going to store on this variable. So now we need to print on it now. So for the printing we can the log. So next line you have to type as the it is the manually you need to type on it. They will not mention the examples. So log of you have to type the variable values. Here also the same form specifier you have to use. So integer means percentage D. This double quotes you have to mention, comma, same concept D. So log variable. So log the variable value is percentage D, like what we used in the syntax of C programming for print the statement. Same thing we have used it. Integer means that using the percentage D, mention the double quotes. So what is the value I want to print it? I want to print the D. Okay. Got it? So now you just compile the code and you have to run it. So in this message window you have to see the variable value is 0. So parallelly you have to change the system variable value. Now double click and you set as a current value as a content. And click OK. Now you have to see the message window the value is a content. Yes. So if you have background we have under the capital scripting. For example, we are using a condition for the remote keyless entry. The capital scripting is running. We are setting the timer as a so whenever you receive the RT ID number 128. So on the first bit log value is 1 means you have to automatically set the indicator turn on. Means the script is background running. So whenever the value passes at the time, its automatically indication will be turned on. Now this variable value we will change it parallelly back and memory. So now the code is looking at back and so now the variable value we have to change it. Now I can change the set 10. So now the system message value change the set 10. We don't need to change any code. So based on the condition, automatically code will be executed. Okay. So now we are just checking with only the printf statement everything. So next one is the communication.
For that variable, we are fixing input value and maximum value. In between that range only we print the value.
Yes.
But if I give out of the range,
yes.
current value.
Yes. It will not take or it will take as a random or big values. You can try that also.
I have given 500, but it is printing.
Continue. But actually maximize it will not check it for conditions. I think nowadays we are using the log printing, we are using log, so that maximum is taken up, but in the condition then it will not take. If you are working with a variable value greater than or equal to 10, less than or equal to that kind of conditions if you are working means, and the places if you are using the final means take as a garbage values or anything. Okay. Yes. So I think today topic we just recorded up to this time as well. So tomorrow morning we have to enter the CAN message. Okay. You once again check with this capital scripting because now in this instead of time ourselves we are going to transmit some new messages. So if I start this means the time is not enough. maybe times 850. Okay. So you just check up to this diameters, start to stop to this event if your strong that is fine now. So tomorrow we have to check with the functions of which one? Com. So the communication we are having the can RBS signal value, set signal value vectors, get signal value vectors.
So in com means we use com.
Yes, com. Communication data RBS can RBS like that. Right. So then we are having some fault projectors also. How to do the fault project, how to clear the fault project. So now this is enough.
So, you can sign that.
Personal consent.